In the last session, we talked about the L2 responsibilities of the Open Central Unit, which are PDCP and SDAP protocols. In this session, we will be talk about the L3 responsibilities of Open Centralized Unit. We will talk about the radio protocol architecture and RRC. We will also brief the states of RRC. So this is the high-level architecture of protocols, and this shows that how the data gets transferred from higher layer to the lower layer. This is the diagram of the user plane. As I said that SDAP is only used in the user plane, and when we talk about the RRC, then it is completely the control plane information. So SDAP, we talked that the IP packets coming from the upper layer, SDAP protocol add the QFI information on those packets and then forward the packets to the lower layers through the radio barriers. Then the PDCP have the responsibility of separating and header compression. PDCP also do the disaggregation of different radio barriers for master and secondary cell groups in case of dual connectivity or multi-connectivity mode. Then those SDUs comes down to the lower layers, which is RRC protocol, and then more down to the MAC layer protocol, where these IP packets and radio barriers gets converted into the transport blocks. If there are multiple carrier serving, in case of carrier aggregation, which is very common in 5G and also used in the 4G, then MAC has the responsibility to manage the aggregation of data between the carriers. And then these transport blocks are being transferred down to the physical layer, which will map the transport block into the physical resources in the frequency domain and the time domain for the transmission of data. It also includes mapping of information based on the modulation schemes, beam informations, etc. So this is how the data flows in general. If this is clear, then let's talk about the RRC layers. So RRC is Radio Resource Control Protocol. This is the L3 layer or network layer in the OSI model. RRC only contains the control information, means no user data or payload transferred over the RRC protocols. RRC protocol responsible for initial setup and access of network. It is responsible for connection establishment between the UE and the base station. It is also responsible for release of connection. There are different broadcasts of the system information which is being continuously broadcasted in the downlink by the base station, which tells users about the network. RRC is responsible when users wants to move from one cell to the another cell. RRC tells users that what are the different criteria of hand in or hand out, what are the criteria of even selection of a cell, like we call the cell selection and deselection. RRC tells about the need of radio barriers and helps in establishing the radio barriers between the UE and network. For the configuration and reconfiguration of any stage for any services, RRC is mandatory. From initial registration to the access of service, from paging to notification, changing in services, addition of carrier aggregation, new carrier configuration, all the steps are being handled by the RRC. This also takes care of the power control, means it guides the UE and the base station that at what optimum power UE should transmit the information depends on the radio conditions. Now you think it right that this is one of the most important protocol to understand. If we talk about the general stages of RRC, then these are RRC idle, then RRC inactive and RRC connected. However, 4G mainly have the RRC idle and RRC connected, but 5G also have the RRC inactive state as well. So in RRC idle mode, there is no direct connection between the UE and network, just high-level tracking information is available. No data transfer is possible when RRC is idle. There is no RRC context and there is no connection of UE with the core network. In the case of RRC connected mode, UE and network has a valid established connection and radio barriers through which the data transfer is possible, either a voice call or payload data, anything. Let's talk about the registration management and the connection management. As this is very clear with the name that registration management, it basically starts the registration of the UE with the core network. After the UE registration is complete with the core network will have all the valid locations and routing related information of the user. So once the registration is done, it is called RM registered mode, else it is RM deregistered. Next is connection management, which comes in picture when UE require the NAS signaling connection with the AMF. The states can be CM idle or CM connected. So the UE is in the RRC idle, then at that time there is RM deregistered and CM is also idle, means there is no connection between the user and network, and hence no data transfer is possible. There is no RRC context is enabled at that time, and there is no connection with the core network. Cell reselections happens by the UE when they are moving from one cell to another. That happens by absorbing the same information transferred by the G node B in the downlink. But now when the RRC is connected, this means RM registration is done and AMF also have the information of UE location. Also, when RRC is connected, this means the CM is also connected for NAS signaling between user and core network. Established a connection does not mean that the data is transferring actively. Hence, this new stage comes when there is established connection between the user and core network. This means RM is registered and CM is also connected, but there is no flow of user data or payload. There is RRC context established, but no user data flow. This stage is called RRC inactive. The benefit of RRC inactive is whenever there is any need of user data flow between UE and network, the data transfer can live in very minimal time because the connection is already exists there, hence the response time and the latency will improve. Because the steps of RM registration and CM connection is no longer needed from the very start of service because it is already there. You can relate it with the very simple state machines in the screen. So at first UE is powered up, so it will be in RRC idle mode, means there is RM deregistered and CM is also idle. Now the RRC connection request made and the state will change to RRC connected. Now if because there is no user data transferred live, it will move to RRC inactive stage. If demand of user data barrier comes, it goes back to RRC connected stage. If connection fails at any point of time, then it will go back to the RRC idle state. When the state is RRC connected, then if RRC release request is received, then it will go to the RRC idle state. Also, if RRC connection fails at any point of time because of any reason like radio condition, it will again go back to the RRC idle state. During the RRC connected state, if RRC suspends, then it moves to the RRC inactive state, and if RRC resumes, then again it goes to the RRC connected state. Simple. In the next session, we will be introducing the machine learning concept and intelligent controllers in the OpenRAN ecosystem. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.